Welcome back, everyone. We are going to continue with activity 4.1a. This is part 2 of that activity. And one of the things that I left off from the previous video was the objectives. And from now on, what you will see at the beginning of each activity are the objectives for that activity. And we will review them when we start and probably when we finish each video. So, in the last video, we had an overview of Chapter 4 about collecting data. We took a look at what random sampling is and why it's important. We discussed how to use your calculator to generate a random sample, and we discussed what bias is and how does it happen. In the second part of this activity, we'd like to address examples of different types of bias and the impact of each, the definition of what we call a simple random sample, and how to use a random digit table to select a simple random sample. So, as was pointed out in the first video, bias is one of those things that we want to avoid, and one of the things that we have to do to help us eliminate bias when we're selecting samples or subjects for surveys or collecting data is to use randomness in the process. If we don't, then it can lead to bias. But using randomness alone doesn't eliminate bias. So we'd like to address a couple different types of bias and talk about their impacts. For your information, the College Board is not so big on you remembering the names of the types of bias, but typically what they would do if they asked you a question is they would ask you to describe the bias that is occurring and its impact on the data that was collected. In the rectangles example, if you recall, about 2/3 of the data that we collected resulted in samples that overestimated the true population average area. That's an example of what we call a selection bias. And I don't know the psychology behind it, but what I believe it's related to is our tendency to notice things that are large relative to the entire population. So generally speaking, what happened there is we had a selection bias where we tended to pick 5 rectangles that were above or typically above average compared to the entire population. So in number 4, here's another example of bias. So it says, you may have noticed that television news stations like to conduct call-in polls of public opinion. The station will announce a question and then ask viewers to call a particular telephone number to respond yes or another number to respond no. The ABC show Nightline once asked viewers whether the United Nations should continue to have its headquarters in the United States. More than 186,000 callers responded and 67% said no. Do you think that 186,000 is a large enough sample? Now that might be hard for you to make a decision on, but the reality of it is that it's way larger than it needs to be. If you pay attention to exit polls, for example, very often excellent exit polls consist of 900 to 1,500 subjects, and they get results that have small margins of error. In other words, they're probably accurate to within 2 to 5%. How much confidence would you have that 67% who responded no represent the greater population of the United States? Describe the type of bias you believe may be present, if any. Well, there might be a couple of types of bias going on here. One of them would be a selection bias because the producers of the show Nightline are only selecting people to ask that question that are viewing the show. And if they tend to have a particular view about the United Nations that different than the rest of the population, then it could lead to an inaccurate result because of a selection bias. On the other hand, one of the other things that's going on here is even if the subjects that are watching Nightline are a good representation of the entire population, the only way that a subject gets to be counted in this survey is if they decide for themselves. This is often called a voluntary response, which leads to a voluntary response bias. And in that case, usually what happens is you get data that skews one direction or the other because it tends to only be people with very strong opinions about the situation. Here's another example. Often you will find volunteers in shopping malls gathering information by conducting surveys. This is typically a fast and inexpensive way to reach a sample of the population. Do you think that people who shop at malls represent a random sample of the population as a whole? Why or why not? Well, the first thing that has to be asked here is, what do we mean by the population as a whole? Are we talking about only the people that shop at that mall? People that shop at malls in general? The entire population of the U.S.? The entire population of the world? Because only then can we answer that question. So let's say that it's representative, that the question is concerned about the entire population of the U.S. and that this mall is located in the U.S. So if we have somebody gathering information by conducting surveys from people at a mall, if they are not randomly selected, that's going to be a problem. And that can happen just like selecting random rectangles can lead to a bias. Even if they are randomly selected, the subjects that we are selecting, those people shopping at this mall, in all likelihood are not a good representation of the entire population of the U.S. In part B, it asks, do you think that the person conducting the survey may tend not to choose certain individuals to include in the survey? How might that impact the survey results? Well, I don't know about you, but sometimes I see people that I'm intimidated by. If I were the person out there doing the survey, I would avoid people that I'm intimidated by. So in that vein, I could be adding bias to the situation and therefore impacting the survey results. Another example of bias can result in how we pose the question. Even if we randomly select the subjects to answer a question, how we pose the question could lead to bias. So here's an example in number 6. Given that the threat of nuclear war is higher now than it has ever been in human history, and the fact that a nuclear war poses a threat to the very existence of the human race, would you favor an all-out nuclear test ban? Describe the bias in the wording of this survey question. What would be a more appropriate way to word this survey question? So if people respond in a way that doesn't truly represent their feelings, it's considered a response bias. And a poorly worded question is an example that can lead to response bias. What we really want to know in this question is, would you favor an all-out nuclear test ban? But everything in that question that precedes it biases the person responding that question to answer yes. So what that would tend to do would tend to overrepresent the portion of the population that actually favors an all-out nuclear test ban. A more appropriate way to phrase that question would simply be to ask this portion of the question right here. Would you favor an all-out nuclear test ban? Take a moment and read this Wizard of Id cartoon and then answer the question above. Describe the type of bias present in the cartoon below. So let's say in this cartoon, the person doing the survey is actually randomly selecting the subjects. Well, we've done what we can to avoid a selection bias there, But if you notice, the choices for the survey are going to lead to a response bias. Would you say the king is doing a good job, an outstanding job, or a terrific job? None of those allow for the king doing a mediocre or a poor job. So even though you collect responses from, let's assume, randomly selected subjects, the respondents may not truly reflect their opinions. That's an example of a response bias. Again, there's various types of bias, and the College Board is not so big on you knowing the vocabulary of the type of bias, but recognizing the type of bias that could be occurring and explaining how that could be impacting the results. Going back to random sampling, a very common method, a very important method for selecting a random sample is called a simple random sample. And we're going to talk about this more in depth in the next activity, but Ms. Harding and I wanted to get this definition out to you and get you to start thinking about it. The type of sampling that we did with the random rectangles was a simple random sample. And a simple random sample requires two things to happen. Number one, all subjects have to have an equal chance of being selected. So each of the 100 rectangles had a 1 out of 100 chance of being selected. And all groups of subjects have to have an equal chance of being selected. And in our example, we selected groups of size 5. And n, lowercase n, represents the sample size. So all groups of size 5 had to have an equal chance of being selected. And if you wanted to figure out the number of groups of size 5, you could do 100 choose 5 on your calculator and see that is a very large number. Turns out that if we were going to select all samples of size 5 from that group of 100 rectangles, it would be 75,287,520 different groups of size 5. Each of those has to have an equal chance of being selected for it to be a simple random sample. And in our case, they were all equally likely to be selected, so we did select a simple random sample. As I said, this definition is a little bit challenging to work with sometimes, and we're going to spend some more time on it in the next activity. Very often, the definition is not specified with these two criteria. It just says all groups of size n greater than or equal to 1 have to have an equal chance of being selected. I think it's easier to break it down into two things. Number one, does each subject have an equal chance of being selected? And number two, often the more challenging one, is do all groups of subjects of a particular size have an equal chance of being selected? The last thing that we want to talk about is another method of selecting a simple random sample using something called a random digit table. And I'm going to use our random rectangles example to illustrate that. You may have noticed that the rectangles were numbered with two-digit numbers starting at 01 and ending at 00. And though it might be strange to number things using two digits when it's not necessary, or they typically one digit, it actually makes sense when it comes to using a random digit table to select the random rectangles. Here's the idea behind it. There are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you're selecting single digit numbers from a random digit table, they have a 1 out of 10 chance of being selected. If you're selecting double-digit numbers, there are 100 double-digit numbers. Each of those has a 1 out of 100 chance of being selected. If you're selecting triple-digit numbers, there are 1,000 of those, 000 through 999, and each of those has a 1 out of 1,000 chance of being selected. So if we're using a random digit table to select subjects for a sample, the first thing we want to do, particularly if it's a simple random sample to meet that first criteria, is we want to make sure each subject has an equal chance of being selected. So the easiest way to do that is use the same number of digits to assign a digit to each of the possible subjects, which is what we did here with the random rectangles. So now we're going to move down to the actual random digit table. And I'm going to make this a little bit bigger. Since it's a random digit table, it doesn't matter which line you start at. Typically what we do is we pick a line to start at, and then we go through and we start reading off digits that represent the outcomes for our sample. So to keep things simple, I typically start at the first line in the random digit table. And in this case, we have 100 random rectangles numbered with 2-digit numbers from 01 to 00, or you can think of it as from 00 to 99, and we need to select 5 different random rectangles. So the easiest way to do that would be to start by counting off double-digit numbers: 19, 22, 39, 50, and 34. And those would be the numbers of the rectangles that I would select for my sample, and then I would go back and I would record their actual areas to calculate the average area. Just like with the calculator, if for some reason 2 of these numbers were the same, then you would just go on and select another 2-digit number. So let's assume for the moment that our third double-digit number, 39, and our fourth double-digit number were the same number. If we're selecting a sample of size 5, we mean 5 unique subjects in that sample, no repeats. So what we would do is, if we got a repeat, we would go on and select the next double-digit number, which would be the number 5, and then that would be our subject. And we keep doing that until we get 5 different subjects. It's a relatively easy thing to do, but one of the things you have to ask yourself when you're using a random digit table is, are we meeting particularly that first criteria that all subjects have an equal chance of being selected? One way that you can create a situation where that doesn't happen is, for example, if you numbered the rectangles not 0, 1, but 1, 2, 3, and so on with single-digit numbers, and then you had a bunch of double-digit numbers, and then your 100 was a 3-digit number. Well, single-digit numbers have a 1 out of 10 chance of being selected. Double-digit numbers, a 1 out of 100 chance of being selected, and triple-digit numbers, a 1 out of 1,000 chance of being selected. So I would recommend, if you're using a random digit table to select subjects for a sample, that you number them in such a way that each one has the same number of digits, so that when you're selecting the digits, you always select the same number of digits, 2 digits or 3 digits or just single digits. Another thing I want to point out here is, let's say that our sample size, or not our sample size, but our population only had 50 rectangles. Well, what would you do then? Well, what you would do then is you would only use numbers in the range that we actually have subjects to represent. So let's say we started at line 105 and we had rectangles numbered 01 through 50. Well, 95 is not one of our rectangles, so we would ignore it. 59, not one of our rectangles, so we would ignore it. 29, that would be the first one that would be in our sample. 40 would be in our sample. 7 would be in our sample. So far we have 3. 69, not in our sample. 97, not in our sample. 19 would be in our sample, and we're currently at 4 rectangles, and 14, and then we would stop there. So that's how you use a random digit table to select randomly from a population. Let's go back up here to the top and address our objectives and make sure we've talked about all of them. Examples of different types of biases and the impacts on each. Again, focus on being able to describe and explain how that bias is having an impact on the sample data, not focusing too much on the vocabulary. Definition of a simple random sample and stressing the two criteria. All subjects have to have an equal chance of being selected, and all groups of subjects of the same size have to have an equal chance of being selected. And finally, how to use a random digit table to select a simple random sample. Again, make sure that each of the subjects has an equal chance of being selected. The easiest way to do that is to assign the same number of digits to each of the subjects. And if you're not going to use all the digits, that's fine when you're reading them off the random digit table. Just ignore them.